Okay, I'm going to show you some of the two of the special cases when you're graphing linear systems. The first one is when I look at this equation, I have y equals, and I'm going to just zoom this a little bit closer so you can see it better. And what we have here is we have y equals negative 6 over 3x minus 3. Now, what's odd about that is that fraction is not in simplified form. So what you want to do is you want to simplify it. So negative 6 divided by 3, that's negative 2x minus 3. Now, what that should look familiar to you is it's identical to the equation below it. When that happens, you'll think that you're going to be able to recognize it right away, and I hope you do, but sometimes we get in a zone and we just start, well, I got to graph all these, and then you graph them, and then you don't realize, hey, something's wrong here. So I got negative 3, but then when I go down 2 and right 1, I start going off the graph. So instead of continuing that way, I'm going to do what I call my sister move. So remember, negative 2 over 1 is your slope, so that's down 2, right 1. But positive 2 and a negative 1, where you'd go up 2, left 1, both of them divide to the same value. So this is a legal move. So you can go up 2, left 1, up 2, left 1. All right, now we put that into consideration. And what we do next is we draw our line. I'm going to draw a green line here. And then when we're finished with that, we'll look at the other equation, which just so happens to be the exact same equation. So you're still at your negative 3. You're still at all these points. The only difference is we have a line directly going over that, and we wrote it twice. So this is an example where every single point from the red line is exactly with every single point of the green line. So we will answer that as infinitely many solutions. And that is different than all real solutions because there's an infinite amount of points on a line, but not all solutions are real. There's a whole bunch of this grid that we never touch. So it just says that there's an infinite amount of solutions. It doesn't say that they're all the solutions because, again, over here, these aren't solutions. Now, the other special case I want to show you is when you look and we have a starting point of negative 3 on this one. So we start at negative 3, and then our slope indicates 4 over 3, which means we go up 1, 2, 3, 4, and to the right 3. Okay, now that's pretty good for the graph. Now sometimes I like to have more than that many points, but for now I'm just going to go ahead and say that's pretty good, and I'm going to draw my green line through it. Remember, you don't want to just stop at these 2 points either. Then your next one, it says the starting point is a positive 2. So I go back to my origin, I go up to 2, put a point, and again, I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. Now, I could do what I just did there and kind of extend the graph, but this is when I talk about those sister moves being so important when our graph runs out. You have 4 over 3. Well, that's the same thing as negative 4 over negative 3. Both of these will give you a positive 4/3 when divided through. So I can go down 4 and left 3 and be at that same line. Again, you want to use a straight edge because human error will make it not look true. Okay, so when I do this and I go through, what you'll hopefully notice, and maybe you even noticed before we started, is that when the slopes are the same, look what happens. These lines are parallel. So if you're in geometry, we show parallel lines with these little arrows in the middle of the line, like to show like this line is parallel with this line. I don't know if you've seen those, but this would be an example of no solutions. Okay, because they never cross. No solutions. All right. All right, well, if you want to just continue, and like I said, if you come across any that give you problems, feel free to leave a comment and I will adjust the video. Thank you.